everybody, I thought I'd make a video to help you with either GRPSS or GRAPS, and we'll determine which one we need in a moment. Take a look at what we've been given. We've been given that DF is equal to EG, so the length of DF equals the length of EG, and we need to prove DE equals FG. DE equals FG. So let's take a closer look at that. We know from D to F, that entire length, is equal to the length from E to G. We also know that we want to prove that from D to E is equal to F to G. The pieces that we have congruent are larger than the pieces we want to prove congruent. So therefore, we need to make the pieces smaller because we're going from this piece to this one. We need to eliminate EF. And we're going from this piece to this one. We need to eliminate EF. It's going to be subtraction. Therefore, it's not GRAPS, it's going to be GRPSS. Let's write down what we need. We need G, we need a pen, that's what we need. G for given, R for reflexive, P for partition, S for substitution, and S for subtraction. Let's number ourselves up. Partition, we will need a little bit more space, so I'll put 4 here and 5 here. Let's get started. The first step is the given. Why don't you pause the video and put your given in with the reason, and then I'll come back. You should be doing the proof at the same time I am. I'll be right back. Okay, let's move on. Now we need the reflexive, R for reflexive, and that's the piece that they share, the overlap. It's also the piece we will subtract later. We're going to write for reflexive, EF equals EF. In reflexive, you always have something equal to itself, not equal to something else. I'm going to abbreviate here. Next step we have is partition. Partition says a whole is equal to the sum of its parts. In this case, a whole segment is equal to 2 segments being added up. What whole are we talking about? Well, we're going to be talking about DF and EG. DF, let's talk about what that's made of. DF is made of, look at the 2 segments that make it up, DE plus EF. DE plus EF. The next segment is going to be EG. EG is made of EF plus FG. Now, how did I know to take those 2? You're probably wondering. Let me fix that. Well, they were the only 2 bigger segments. This was a bigger segment that I knew about, and this was the other whole segment. So I took the whole segments that I knew about. Next step, S for right here, for substitution. What are we going to substitute? Let's take a look. This is the step I currently have. When you're using substitution, you need to look up what came before. Something here must look identical to something that came before it. Take a look and see if you have a match. And we do. The DF and EG were up here. DF equals EG. This is DF, this is EG. So these 2 must be equal. I say in class, if the left side is a match, then the right side must be a match. Therefore, we can substitute to say that DE plus EF will equal EF plus FG. Oh, we forgot to write our step here, which was partition postulate. As long as we write it down. And step 4, substitution property. Hopefully you see where we substituted. we want to prove, take a look at your proof, DE to FG. DE equals FG. It would be nice if I could get rid of this EF on each side. If only I could get rid of those. Well, we can, because we know EF equals EF. These two are equals. So we take our equals, subtract our equals, and we'll be left with equals. DE equals FG by subtraction. We're basically subtracting out these pieces. So by the subtraction property, we've proven that DE is equal to FG. Done. Hopefully that helps. You can watch this again. You can do the proof over again for practice. That was GRPSS, making segments smaller, subtracting out a piece that they both share. I'll try to find a GRPSS proof and do that with you as well. See you in class.